Yes, so we will have a small change in the valedictory slot. We will begin with Scientific Secretary of Office of PSA's a keynote address first, so that there is no contingent plan in terms of reaching the airport. And then we will continue with the fireside chat, for which from the Australian side, although Kathleen is with us representing the Australian Consulate General here, we have an expert coming from Australia, so we would have Professor Andrew White for that fireside chat. Now I request Professor Navakanta Bhat to start the valedictory session with the keynote. Over to you, Professor.
Thanks very much, Dr. Chagun, and in the interest of time, I will be very brief. It's indeed a privilege to chair this session, and as Chagun said, we have a little bit change in the sequence. We'll get started with the keynote. So we'll not call it valedictory keynote, because fireside chat will be the valedictory event. The keynote will be given by Dr. Parvinder Maini, who is the Scientific Secretary at the Office of Principal Scientific Advisor to the Government of India. And in fact, I'm sure she has been one of the main person in also planning this whole event. So with that perspective, she's going to talk to us on driving sectoral transformation through independent and synergistic technology advancement. Over to you, Dr. Maini.
Good evening, everybody. For the last one day, of course, we have been engaging in very good conversation, discussing different technologies and how we need to collaborate on that to drive growth and innovation and transformation. While, of course, individual technologies are very, very important for transformations, we also need to bring in synergies to see how we can grow together. So we are living in an era where technology is just not a tool, it's a key enabler of economic growth, national security, and sustainable development. Now there is a rise of disruptive new age technologies and their transformative impact that we all are feeling on the socio-economic systems. Countries around the world are increasingly positioning technology as a strategic asset in all their international engagements. This facilitates a balanced global competitiveness, strengthens resilience against emerging challenges, and supports the transition to a more sustainable and inclusive growth. Technology, of course, touches every aspect of life and holds the power to define the trajectory of the nation, of the countries, of the region. However, it must be harnessed with purpose, should be guided by vision, and deployed in ways that are inclusive and sustainable. India, of course, we have been hearing, it's poised to be the third largest economy in the years to come. So research and development, enhanced technology adoption, skilling, and increased trade collaborations have emerged as the key imperatives for the next 5 years that will not only enhance productivity, but foster innovation and reduce dependencies. Various initiatives have been taken by Government of India, like we have been hearing, the Digital India, the Startup India, Make in India, and various technology missions have been launched, exemplify the pivotal role of technology in transforming governance and economic structures. Now, digital transformation, of course, has emerged as a formidable force, propelling the nation's advancement in various sectors, including healthcare, education, and so on. Cutting-edge technologies such as quantum computing, AI, machine learning, and the Internet of Things have revolutionized service delivery and promoted ease of doing business. The Startup India initiative has helped India grow by creating jobs, boosting GDP, and attracting foreign investment. Today, India has the third largest startup ecosystem and over 100 unicorns. Although the GERD as a percent of GDP has been almost stagnant for the last 3-4 years, the startup ecosystem has helped to build a strong ecosystem for innovation and entrepreneurship. Today, startups have diversified from software-related services to agri-tech, ed-tech, and cutting-edge manufacturing industries like electric vehicles and space tech. Added to this, of course, as I mentioned, Government of India's Make in India and Atmanirbhar Bharat, together with a conducive environment that we have created for investment, innovation, and entrepreneurships, had transformed India into a global manufacturing hub. India, of course, as we heard in the last one day, has engaged with global players on strategic partnership like the ISET with the US. We have the India-EU Trade and Technology Council. Then we have the Technology Security Initiative with the UK. All this highlight the growing importance of technology on the agendas of major international forums and bilateral engagements. The Quad, comprising of India, Australia, Japan, and the US, has evolved into a multifaceted forum addressing a wide range of regional issues beyond traditional security concerns. In summary, the technology-driven global engagements bolster India's strategic autonomy, economic partnership, and leaderships in emerging global value chains. Therefore, the technology dialogue that we have had today, and it's a dialogue which we started a year back, it's in an event where we hope to organize annually. So this gives us actually an opportunity to discuss some of the emerging and frontier technology with various partner countries and also the policy issues around them. And in the Technology Dialogue 2025, we had different panels discussing different advanced technologies like AI, quantum, space sector, semiconductor, bioeconomy, and so on. We have now seen how the role of AI in India's growth has been transformating, positioning the country as a global technology leader in leveraging AI to address economic, societal, and developmental challenges. AI, of course, has revolutionized the world by various through its scalable and efficient solutions. So today AI is driving advancements in areas like quantum computing, space exploration, and biotechnology, placing India on the global map for innovation. The India AI mission, which has been launched recently, which we discussed extensively, is a transformative initiative that is driving India's ascent to a global economic power by strategically leveraging AI to boost innovation, inclusivity, and industrial competitiveness. Quantum technology is another area that we had been discussing. This has emerged as a transformative force in shaping India's growth trajectory and driving innovation, improving security, and boosting economic competitiveness. By investing strategically in quantum computing, communication, and materials, India is positioning itself as a global leader in the quantum revolution. India's comprehensive approach to driving research, development, and the practical deployment of quantum technologies in areas like cryptography, quantum computing, and secure communications are unlocking new possibilities across security, industry, and research, driving the nation's growth trajectory. India is making, of course, a strategic push to establish a domestic semiconductor industry, driven by the need to reduce reliance on imports and mitigate global supply chain vulnerabilities. The semiconductor mission, which was launched in 2021, is a crucial step for national security, especially in sensitive sectors like defense and telecom. India's rise in the global semiconductor industry is being propelled by robust policy support, such as the production-linked incentives, which is attracting global players to set up operations in India, and also the skilled workforce that we have. With its strategic location, growing market, and innovation-driven approach, India is well positioned to become a key player in the global semiconductor supply chain and drive the future of technology on a global scale. Now, when we come to the space technology, we have heard in the morning in the panel the kind of advancements India has made and its leadership in peaceful space explorations. These have been instrumental in driving its economic growth, technological innovation, and global influence. By addressing national priorities like connectivity, agriculture, disaster management, and defense, enabling policies to boost space startups, and fostering international collaborations, India's space program has not only boosted its economy, but also strengthened its position as a global leader in space exploration and technology. Now, coming to the India bioeconomy policy, which we had just the panel discussion, it's empowering the nation by fostering innovation, self-reliance, and sustainability. It is driving economic growth, creating jobs, and addressing critical challenges in healthcare, agriculture, energy, and the environment. By unlocking the potential of biotechnology and aligning with India's broader developmental goals, the policy position India as a global leader in the bioeconomy, paving the way for a prosperous and sustainable future. Needless to say, as I said before, all these initiatives have positioned India in the global arena as a product nation by transitioning from being a global hub for services to becoming a leader in innovation, design, and manufacturing of high-value products across various industries. This vision, of course, is centered around developing indigenous capabilities, fostering innovation ecosystems, and strengthening intellectual properties to drive self-reliance, global competitiveness, and economic growth. The Honorable PM has also issued a clarion call to make the next 10 years as India Decade through the advancement and indigenization of frontier technologies. However, to propel India towards becoming a global manufacturing hub and to achieve national and global competitiveness, a cohesive framework that aligns cross-sectoral contributions is critical. Advanced technologies such as AI, robotics, IoT, blockchain, 5G, and renewable energy, etc., can achieve exponential impact when they are integrated and made interoperable across sectors. Synergies unlock efficiencies, enable resource optimization, enhance productivity, and strengthen global supply chain integration, thereby providing holistic solutions for sectoral challenges like food security, climate resilience, and digital inclusion. However, the independent growth of these technologies is equally essential for advancing sectoral expertise. And for this, regular technology foresight exercise, which we have been conducting, are essential to provide blueprints for harmonizing sectoral priorities with overarching national goals. At the same time, prioritizing capacity building, IP development, and strategic investments ensures that technological growth serves both domestic needs and global ambitions. India is, of course, looking forward to adding more impetus to its technology diplomacy efforts by combining its technological advancements with diplomatic initiatives to build partnerships, enhance global influence, and address global challenges. For example, the International Solar Alliance and Quad's quantum cooperation showcases India's role in fostering international collaboration for technological progress. Now, as a founding member of various multilateral initiatives, such as in G20, India is leveraging technology diplomacy to shape global norms and frameworks in critical technologies. The Chief Science Advisors Roundtable, initiated during the India G20 presidency, which was led by our office, has showcased India's agenda-setting role in global technology engagement discourse. In summary, India stands at the cusp of a transformative journey where independent technological advancements and synergistic collaboration will define our growth trajectory. Let us harness the power of technology and meaningful international collaborations to build a self-reliant, sustainable, and inclusive future, making India a beacon of innovation and global leadership. Events such as the Technology Dialogue 2025 provide a collaborative and multidisciplinary platform to facilitate a discussion on exploring new frontiers in technology diplomacy. We hope to continue this enriching discussion beyond this platform and hope that we continue this technology dialogue in the years to come. Thank you so much.
Thank you, Dr. Maini, for a wonderful summary of emerging technology landscape and the importance of working synergistically to achieve, the future that we aspire for. So, with that, we will move on to the last session, last event of this session, rather, which is the fireside chat. May I invite the two panelists, Mr. Utpal Shah from Tata Semiconductors and Professor Andrew White, University of Queensland. If you can come on stage, please. Thank you. So, as you know, the The topic of this panel is positioning India in the global semiconductor value chain. So the way we would run this panel, I will begin with some opening comments and then request the panelists for their opening comments and follow it up with a few questions. Semiconductor chips today are all pervasive, and we have learned it through the COVID pandemic. That's when we realized the importance of supply chain. And it turned out that, many sectors, we were not able to get access to products simply because they in turn were not able to get access to the chips. And that's how important the semiconductors are today. In fact, semiconductors are the oil for the current IT-based society. And it's indeed very important that, we position ourselves strategically so that we aim and we aspire to become one of the global leader in this area. And indeed, if you just look at the semiconductor chips market today, in just a couple of years, it will approach $1 trillion. And if you look at the electronics and computing market, which is of course fed by the chips, that is expected to touch $10 trillion. So it is just huge. And also, if you look at the geopolitics of what is happening in semiconductors, right? Majority of the semiconductors are produced in Taiwan. In fact, if you look at the advanced chips, about 90% of the advanced chips are produced in Taiwan. And China, which was nowhere in the picture, if you look at overall chip production, not just the advanced chips, then it's already at 15%. So a very small geography sort of defining how the technology of the world will move forward is a big concern. And that is why many nations have come up with their own strategies. For instance, the Chips and Science Act in the US. One would have never thought that semiconductor manufacturing will happen in the US. But today, most of the new fabs are being set up in the US, including TSMC setting up one of the biggest fab in the US, right? Similarly, India has India Semiconductor Mission, $10 billion US, a huge outlay that government of India has provided. The intent is again to realize self-reliance in semiconductor manufacturing. So I also want to put the context because that will be important for the panel. India has been doing very well in semiconductor design. It started off in 1980s with Texas Instruments establishing its first design house in India. And today, 20% of the design talent of the world is in India. Almost every company that you can imagine in semiconductors have their R&D facility in India, right? So that is how well we are doing in terms of chip design. But when it comes to semiconductor chip manufacturing, we are taking baby steps. We have a long way to go. I think the panelists will also be able to address that aspect. Indian semiconductor consumption is very close to $100 billion US already. So it's very, very important that we take the right steps going forward. And also in the context of, again, geopolitics that is emerging, Quad is a very important grouping, and we have representation from India and Australia in this panel. And we also share at least these two countries in the Quad. Cricket also binds us. So I think we have a very interesting panel here. And with that opening remarks, I request Mr. Utpal Shah, who has spent many, many years in Intel. In fact, he has driven Intel's foundry business in the US. And now he is leading the semiconductor aspirations at Tata Semiconductors or Tata Electronics. Over to you, Utpal.
Thank you. So first of all, thank you, Professor Bhat, for the kind introduction. On behalf of our CEO, Dr. Thakur of Tata Electronics, and our group chairman, I would like to sincerely convey my appreciation to the MEA, PSA, and the Indian Institute of Science for hosting this technology dialogue. It is also my pleasure to share the stage with the Australian representative professor here and with the distinguished professor, Mr. Bhat. Let me begin by introducing Tata Electronics. So I think as many of you know in the audience, the Tata Group has always been on the forefront of nation building in India. Whether it is about the steel industry or the aviation industry or the automobile industry, IT industry or the power industry, Tata Group has always come forward and led this industry development in India from the front. So today, as the country is in dire need of semiconductor manufacturing, Tata Group has yet again come forward and leading the establishment of the semiconductor manufacturing industry in India, and we are very proud of that. All throughout this journey, the support and vision from the government of India has been very, very instrumental, and I'll talk about that a little bit later. Tata Electronics was founded in 2020 in the midst of COVID, when the entire electronics and semiconductor manufacturing supply chain was severely challenged. The company was founded with the vision of providing end-to-end solution for the entire electronics and semiconductor manufacturing value chain. This is comprising of system-level manufacturing, like for the smartphone devices. But also, if you go down into the devices, our company, Tata Electronics, also provides solutions for components manufacturing that go into the devices, as well as chip making and chip packaging. And it is one of the only company, actually, in the industry that has a vision to provide this end-to-end capability from system-level manufacturing to chip making to chip packaging, and to also provide any sort of design services that are needed to support this entire spectrum. Semiconductors carries a very high importance in the modern society, because every technology, every modern technology that we can think of has semiconductors in the backbone. The societies are entirely running on digital platforms now. From artificial intelligence to space exploration, and from quantum computing to biotechnology, semiconductor is everywhere. So the importance of semiconductor cannot be overstated. This is why at Tata Electronics we are thrilled to be actually leading the groundbreaking initiatives in the country of establishing the country's first commercial semiconductor fab in Dholera, Gujarat, and also country's first indigenous chip assembly and packaging plant in Jagi Road, Assam. These two projects are already going through rapid construction as we speak. There is a total investment of about $14 billion. It will generate, the fab will generate 50,000 wafer starts per month in terms of capacity, which will churn out about 1 billion chips in a year. And the packaging plant in Assam will churn out about 14 billion chips in a year. Collectively, these two projects will create, including the ecosystem, will create about 50,000 jobs across the states of Gujarat and Assam. So we are very, very thrilled with the progress that we are making and the fact that we are bringing the semiconductor industry in India. These two plants are not just manufacturing plants, they bring the entire ecosystem to India. They bring the supply chain. Many of the companies, more than 200 companies have already approached us in terms of setting up their local presence in the state of Gujarat and Assam. So as Tata drives these manufacturing plants, we are actually also establishing an entire ecosystem of semiconductors in these regions. And so you can definitely look forward to Gujarat and Assam becoming semiconductor hubs, semiconductor cities in 5 to 10 years from now. I want to now just talk about the role of government in what we are trying to achieve. The role of government is very, very central. And the government of India, with its decisiveness in defining the semiconductor policy, with its knowledge of the nuances of the semiconductor industry that have been factored into the policy making, with its speed of making approvals for the applications that have gone through. For example, the applications that we had, from the time it was submitted to the time it got approved in the government of India, it was done within a few months for an investment of $14 billion. So this is a record time in the history of, I think, the government of India that they've done it so fast. The ease of doing business with the government of India is unparalleled. And I come from the US, I've seen how the governments operate in different parts of the world. So I don't know how many government representatives are here, but a huge round of applause for the government of India for how they have brought this industry to India. And we are very, very satisfied and extremely grateful for how much support we are getting on a daily basis, not just from the policy making, but from the infrastructure standpoint. These industries need things like water, electricity, effluent treatment, very nice transportation, airports, seaports, you name it. And I think we are getting a huge support from the government, both the central government and the state government, in achieving this very, very huge undertaking that we have on both the fab and the packaging plant in Assam. I want to now briefly just touch on the technology diplomacy, which is extremely important in the business of semiconductor manufacturing. Semiconductor, if you take a step back, the semiconductor manufacturing is not just one technology area. It is actually, broadly speaking, it involves about 11 very distinct technology areas, from designing the fab, to constructing the fab, to the equipments that are used in a semiconductor plant, to the materials that are used in the semiconductor plant, to the lithography masks, substrates, to the specialty gases and chemicals, to the factory automation software, design automation software, and design IP. These areas have to all come together to make this semiconductor manufacturing work. And the point I'm trying to make is that it's not one nation's job. One country alone cannot do it. It has to be a team sport at a global level. Many countries have expertise in different areas. For example, we get lithography equipment from Netherlands. We get specialty chemicals and materials, some of it from different countries in Europe. We have equipment suppliers in US and Japan. We have substrate suppliers in Taiwan and Korea. If you go across all of these 11 areas, it is very spread in terms of where the technology capability is coming from. Therefore, it is very important for this industry to succeed, to have that collaborative spirit between the nations. And the technology diplomacy can actually play a huge role in advancing this industry in different parts of the world. It not only will protect the diplomacy can play a huge role in making sure that we are establishing resilient supply chains so that we are not stuck with one region, that it protects the intellectual property that gets developed through the technology diplomacy discussions, and that it sets the global standards for driving ethical and sustainable innovations across all of these 11 areas that I talked about. So in the analogy of locally in India, we have cricket as a great sport, and we have 11 team members in cricket. These 11 areas in semiconductor manufacturing, they all have to come together and play as one team. The only difference is that it's not a national team, it's a global team. And then lastly, we have technology partnerships that are very, very important. As I talked about these 11 areas, we have already started partnerships with many companies, because you need this technology expertise to succeed and thrive in India. Many of these companies are now establishing their local presence in India. We have partnered with our main technology provider, which is Powerchip Semiconductors in Taiwan. We have also announced partnerships with Synopsys, which is a leading design automation software provider in the US. We have announced a partnership with Tokyo Electron Limited, which is a major fab equipment supplier in Japan. We have also announced a partnership with ASMP, which is a packaging equipment supplier also in Japan. And there are many more partnerships in the pipeline because this business and this Tata Electronics vision, it can only be achieved through global partnerships with global players. To have a greenfield fab and assembly plant in a greenfield country like India, the role of global partnership is absolutely essential. So I look forward to talking about that more, but that's my overall opening remarks. Thank you.
Thanks, Utpal. Professor Andrew, your opening remarks, please.
Mine will be brief. I guess I've got 2 points I'd like to make to open. The first is when we hear the word semiconductor, many of us tend to think, are you talking about computer chips, the kind of things that go into your mobile phone or your laptop? But semiconductor is incredibly pervasive and is the basis of modern society. All of our power systems use semiconductors, whether it be electric cars or solar cells. Our lighting bill, the world's lighting bill, has come down in energy cost and carbon cost over the last 10 years due to us moving to light-emitting diodes. That's semiconductor as well. And all of our communication networks, photonics, is semiconductor as well. So semiconductor encompasses electronics and photonics. It's all pervasive at all layers of our society. And if we're wanting to reduce our carbon footprint, if we're wanting to provide security for our next generation, you really have to address semiconductor. For those of you in the room who know that, I'm preaching to the choir, my apologies. The second point I'd like to make is that many nations had indigenous semiconductor manufacturing capability and gave it up. So Australia in the 1980s, we had 20 businesses that were exporting semiconductor to the world. This year we have 2. Actually, one of them is a university, so 1 business and 1 university. And the Australian governments of all political persuasions over the past 30 years had the opinion, well, the market has decided that that will all move to China, and so we don't need to worry about it. Then after the pandemic, people realised we had the same thing in Australia, huge crunch on manufacture on what we could do when that chain got disrupted. So now we need to have local onshore manufacture. But how can we do it? We're a small nation. We're never going to compete with Taiwan. We're never going to compete with India. So you have to find a niche where you can be part of that global community that you talked about. Last year I was a guest of the Welsh government, and I got to see what they had done over the past 25 years in semiconductor manufacture. They're a tiny nation within Britain. They're 5 million people. That's small, even by Australian standards. But they have set up an export business in semiconductor that's worth £10 billion a year, that's employing tens of thousands of people. And that became the business that supplanted coal as they lost their mining business in the UK. So whether it be a state in India, whether it be the nation of India, whether it be the small country of Australia, there is room, given the pervasiveness of semiconductor in modern society, and given the need for innovation in all these areas, there is room to grow. So I encourage it.
Thank you. So Utpal, you made a comment that Tata has been a nation builder, right? Indeed, even this institute, owes its existence to visionary Jane Tata. Now, you also mentioned that Tata has been in many fields like steel and automobiles, but one major difference with respect to semiconductors is that in steel, the technology may change once in 20 years. In, automobiles maybe once in 10 years, but in semiconductor every 2 years. The Moore's law has been really propelling this industry. In that context, what is Tata Electronics' vision for the next 10 to 20 years? You are perhaps starting at 90 nanometer, but the so-called bleeding edge technology is at 3 nanometer, right? So I'm sure Tata would have been thinking about it. I'm sure many others are also excited to hear about it. So your perspective on Tata's vision, it's
Sure.
not a 100-meter sprint, right? You are actually here for a marathon.
Absolutely, absolutely. In fact, we have this sort of rectangle that we talk about, what are the ingredients for a semiconductor business to be successful. The very first one is the technology. You need to have differentiation on the technology. You need to first have the basic technology, then you need to have differentiation in the technology. The other 3 items, let me cover them first and then I'll come back to technology. You need capital also for this semiconductor business. You need talent, a lot of very skilled labor, and you need ecosystem. So For the capital, this is where the government policies have come in very handy, very aggressive, very holistic, and we are very grateful for the government of India for coming up with these policies. On the talent front, India has a great amount of talent. There needs to be some training, etc., that needs to be done, but we are well placed from the talent standpoint. And the ecosystem, as I talked about, we are driving a lot of partnerships with global partners from the ecosystem standpoint. Now, coming back to technology, our first thing as we looked into the semiconductor business in terms of nation building was to see how do we first acquire the basic technology. It is not something that you can develop organically in a country like India. So we went and explored a few partners, and we eventually signed a transaction with our technology partner, which is Powerchip Semiconductors in Taiwan. We are receiving technologies that are from 28 nanometer all the way to 180 nanometer. So that gives us a very, very good foundation in terms of starting our effort on the technology roadmap. Now, like you said, it's not a 2-year or 3-year journey, it's a 20-year journey. So, like you mentioned, we are very much looking at what is our technology roadmap beyond what we are receiving as our foundation from our technology partner. We have to go below, we have to actually do two things from the technology standpoint. We have to differentiate on the technologies that we are receiving from PSMC, our partner, by creating derivative technologies and creating that technology differentiation on the foundational technologies that we have received. That's number one. Number two, we have to extend the roadmap below 28 nanometer. As many of you know, the semiconductor industry has moved on in terms of the advanced technologies. Currently, TSMC is producing a 2 nanometer technology in Taiwan. Our portfolio with Powerchip is up to 28 nanometer. So we have to bridge the gap from 28 nanometer to 2 nanometer. It's not obviously going to be overnight. We will first have to get into a FinFET technology, which is a 3-dimensional transistor structure, which is something that we are now in discussions with the government of India as to how do we drive a roadmap development for FinFET. And then beyond FinFET, there are more advanced technologies like 5 nanometer, 4 nanometer, 2 nanometer that I think for India to get there, it will take some time. But it's one step at a time from the planar technology, which is the most advanced technology in planar is 28 nanometer, which we already have in the portfolio. From there, we go to 3-dimensional FinFET structure, which will be a 14 nanometer technology. And from there, we continue our roadmap down to the lower nodes, sub 10 nanometer nodes. Now, one thing I'll say is that the innovation, I think earlier in the panel, somebody touched on R&D focus within India, and it's been lacking. It's not, if you compare with other countries, R&D focus in India and the amount of innovation that comes out of India is not comparable with other countries. And this is where we need to collectively, Tata Electronics is looking into how to partner with academia to have more focus on graduate studies, have more programs like what IISc has in terms of masters and PhDs, have a research agenda that is supported like in other countries, US, etc. You have support from National Science Foundation, you have support from Department of Defense, Department of Energy. We have to do those kind of things to actually really up-level the research agenda in India, because having this ambition of going down from 28 nanometer to a FinFET and subsequently down to the latest nodes, academia will have to play a huge role in that, and it has to be a collaboration between academia and industry.
Thank you. Just building on this question, if you look at the evolution of semiconductor industry over the last 5-6 decades, innovation has been the driving factor, right? We have, gone on to many new materials, high-K dielectrics, metal gate, what have you, including 2D materials now. So in that context, what do you think would be the role played by Australian University and perhaps collaboration between Australia and India to, really sort of leapfrog in research for semiconductors?
Oh, that's a big question. All right. So, in terms of the new materials and the new innovation, one of the materials that Australian universities have been looking at for semiconductor, both for photonics and for electronics, is something like silicon carbide. This is one of the new wonder materials. It's got wonderful properties for photonics and excellent for renewable energy, power electronics as well, and that's something that we care very much about in Australia. So that would be an obvious area of collaboration. I'm going to circle around your question a little bit. You were talking about that roadmap down to 28 nanometers, 5 nanometers. There is an incredible amount of useful stuff that you can do with the old 80 nanometer technology or 120 nanometer technology for photonics. That is all you need. You cannot get photonic circuits more than a few hundred nanometers close to each other anyway. So if you've got that level of expertise and working. So globally what we're seeing is people like Global Foundries in the US are taking their old electronics semiconductor fab and repurposing them as photonics semiconductor fab. And that's a new lease of life. And I see a growth path for India there as well. In Australia, we can't do everything. So we have, it's being driven by state governments more than the federal government at the moment. The state of New South Wales is putting together an onshore packaging plant, so we at least have some capability to package in the future. I believe 2 of the other states are now looking at having initiatives in silicon carbide power electronics. And then one of the other initiatives that I think would be very interesting to explore is with lighting technology. So this screen behind us is sand and water, but they're nearly all made in Korea or Japan. There's no reason that someone like India couldn't become the world's largest supplier of screens. Just for your internal market alone, it's 1.4 billion people. Everyone wants a watch, everyone wants a phone. That's a huge market. And again, you don't need that very fine 3 nanometer, 2 nanometer. I mean, I would love to have it, but we'll never have that in Australia. Sorry. And then your first part of the question was, and I've forgotten now. The
possibility of Australian universities and Indian universities coming together. And
there's huge appetite for that.
Enabling that, yeah.
And in fact, I think we heard from the Australian High Commissioner yesterday, our longest running foreign exchange program for science has been with India. My university, the University of Queensland, offers joint PhDs with only 2 institutions around the world. One's in the UK and the other one's in India, IIT Delhi. So there's, for students from both countries, the chance to live and work in the other country is seen as a positive. To Australians, India seems very exotic, but we've got some familiarity with it. We all watch cricket growing up as kids. Mm-hmm. We all eat Indian food. Well, not proper Indian food, but what we call Indian food. And I'm told by the Indian students who come to Australia that it's seen as very exotic as well. Apparently you don't have kangaroos. So, and so culturally it works. And then on the research front, Australia has a lot of innovative ideas. We're very strong in the science, but as I said in the earlier panel, we're very weak on the translation and commercialization, and India is shining at that. So I think there is definitely value add for both countries.
Okay, thanks. Utpal, a question for you. You mentioned that, at Tata, you're also trying to build your design expertise, and TCS is already doing chip design and all that. But what is the strategies for your Dholera fab? Is it going to operate as a pure play foundry to, fill the fab no matter whose design it is, or you're going to work as an IDM and, just address your internal needs for your automobile applications, what have you?
Yeah, that's a good question. So Tata Electronics will be a pure play foundry. It will work with various customers just like any other foundry would. In fact, we have already a pipeline of customers that is a mix of external customers, fabless companies from US, as well as internal customers that are part of Tata Group companies. But the idea is that we create this capability as a foundry. We cater to any fabless companies anywhere in the world that needs our services, manufacturing services. There is a different thread if you are asking about, what is Tata's vision on the design front, that is a separate discussion in terms of, I think, again, India needs to, from the nation building standpoint, there is a lot of presence of design engineers, like you said, 25% of the concentration of all design engineers are in India, is in India. However, when it comes to chip design companies, there are, few and far between, and that scenario has to change. Given that India represents one of the largest concentration of design, there is a big opportunity in India to actually drive that product innovation from the chip design standpoint. And there are now startups coming out with the government's backup from the DLI schemes, design linked incentives. I've seen a few very promising startups in India that are pursuing this ambition of becoming a fabless company that is originating from India.
Andrew, you head the quantum technology lab, and this morning we heard Professor Ajay Sood talking about the National Quantum Mission launched by Government of India. You see, quantum technology is emerging technology. In the next 10 years, we can have a quantum advantage, perhaps, with the quantum computer beating things that classical computers can do. But what is your perspective on how semiconductor technology can really, play as a foundational role for these emerging technologies?
It's an excellent question. I've made this point over and over when talking to Australian governments. You don't have quantum technologies unless you have electronics and photonics. Quantum technologies are merely ultra-sophisticated electronics and photonics, but to build those, you need the base to build them on. And if you can't build power electronics, and you can't build lighting, and you can't build communication photonics, and you can't build logic, then you can't build the quantum technologies, because all of those components are assumed and then extended by that. I have a question for you, actually. So I love Tata's mission. Are you assuming that the training will then happen organically, or are you reaching out specifically to universities to say, look, here are our plans, you should start bringing a workforce on board at this time?
Sure. Can I take this question? Okay. So that's a very good question. Actually, the talent, we are approaching the entire talent domain in sort of three categories, if you will, right? There is an entry-level talent, which is fresh engineers. There is the mid 5 to 10 years of experience talent, and then there's the top leadership talent. For the top leadership talent, these are few people that we need at the very top, so we have been able to bring some expats who are very experienced, and these are about 15 or so positions that need to be filled with the top leadership. So that's a relatively easy task. Relatively, it's still very difficult, but compared to the second category, it's relatively easy. On the entry level, we are working with our, IISc. We have worked with IISc to create a training curriculum for engineers that are graduating with mechanical, electrical, material science degrees, because for them to enter into a semiconductor workforce, there is certain training that needs to be done. If they have not seen a fab or fab equipment in their life, it becomes harder for them to integrate into that environment. So luckily we have a very solid training program with IISc. We are also working with the two IITs, one in Gandhinagar in the state of Gujarat and IIT Guwahati in Assam, to create these centers of excellence for workforce training. As the engineers are graduating from these universities, there is a center of excellence that they, as part of their curriculum, this will be integrated in their curriculum so that when they graduate, they will already have some professional training in semiconductor chip making as well as chip packaging. So that's how we are addressing the entry level. There is a humongous amount of raw talent that we can get from India. The question is about how do you train them, and we have figured some. We are also sending these engineers to Taiwan for a period of 1 year in our technology partners fab in Taiwan, so they can see first-hand experience of the fab. So when they come back after a year of training, they'll be ready to jump into our fab. The issue is with the middle layer where we are looking for in large quantities, we are looking for 5 to 10 years of experience, 15 years of experience, because they do not exist in India. And so we have to figure out some way of bringing them to fill that middle layer.
To tie that back to your question, the reason I asked is that in quantum technology, we don't have an industry yet where you've got people with 5 to 10 years. So we're only worried about that bottom layer. But it's very fungible with the semiconductor industry. If you've had that level of training as an engineer in semiconductor and you come to do some quantum technology, there's only a little bit more we need to teach you. And vice versa. If we've had someone go through a quantum technology program, they then want to work in semiconductor, there's, a lot of the equipment is in common, a lot of the techniques are in common, a lot of the ideas are in common. So that makes for a really flexible workforce space. You have the disadvantage, or the advantage of being in an established field where you do have to worry about that 5 to 10 years, and we don't have that yet in quantum technology.
That's it, yeah. In fact, Government of India has launched many programs for skilling, and in fact, one of the program he mentioned, the Tata Electronics engineers spent 6 weeks in the Center for Nanoscience and Engineering here, going through all the training and stuff like that. So I'm looking at the time, it's 4:16, we have sort of crossed our allotted time. I see some hands raised. I mean, do we also entertain the questions from the audience? Couple of questions? Okay. Maybe just a couple of questions. Yeah, he has one question. I'll come back to you. Yeah.
Most of the engineering colleges who teach semiconductors, they have not updated their curriculum where junctionless transistors are becoming order of the day. Second thing is the manufacturing processes, yield management, etc. They are not part of the curricula as in India. So you have to tell them what is your curricula so that the institutes will generate such human resources, and there should be an interaction between you and the focus institutions.
Absolutely.
That is
I think this is maybe where Professor Bhat is part of Nanoscience Center in IISc, and we know that there has been collaborations with the Taiwanese universities, between IISc and Taiwan National University in Taiwan. This is the model I think other universities in India should adopt, because you're absolutely right, the curriculum is only as good as what India has been exposed to as a country in semiconductor manufacturing. So it's kind of outdated. It needs to be updated with the latest in the industry. And that one way that I think IISc has done it successfully is through collaboration. Is through 2 ways. I think, correct me if I'm wrong, but I think first thing is that IISc Bangalore has stayed up to date with what are the latest innovations in the industry, because they have this master's and PhD program. So by virtue of that, there is a close connection with what's happening in the semiconductor industry, number one. And the second, they've actually taken an effort to have these partnerships with universities in Taiwan and maybe other global universities as well. So that's the model I think that other universities need to adopt.
Yeah, just maybe one here and then, yeah.
Do you want to comment on the last question?
No, I think let's take the, give benefit. Yeah.
Hi, sir. My question is just a small one. So, how you are planning to do with the ultra pure water that is needed for the semiconductor industry, and especially in a state of Gujarat, which is already a water scarce state? So, how you are planning to do on that front? And if I had time, I would have asked you more, but.
Yeah, that's an excellent question. The ultra pure water, for those of you who are from the semiconductor industry, it's absolutely can be a game changer in whether you have high yield or low yield in the fab. So that has been one of our top focus areas for how do we get ultra pure water. We are working with the government of Gujarat to make sure that the water supply they have is matching the standards that we have received from our technology partner in Taiwan. It's not there yet. There are gaps. We will also have international experts like ultra pure water companies like Gradient, Nomura, to establish a water treatment plant in Dholera to assure that the incoming water quality into the fab is of the highest standard. And these companies like Nomura and Gradient and others that are in this business, they know they've done many fabs, they have built many water treatment plants, so they know the specifications very well.
Yeah.
I have two small questions. One is on security aspects, because you are going to be the only fab for some time to come. So to supply to critical industries, I'm talking about critical infrastructure and defense, are you planning to have a secure fab within your fab? So, yeah. Second question is, you are talking about billions of chips coming out of your company. Have you already got the market for it? Because the Indian ecosystem in electronics manufacturing is made to, what do you call that? It's print, mostly made to print. So how are you going to handle that? Because that is the most important sustainable solution to this. Otherwise, we had earlier examples of semiconductors India, did not have any customers. That's why it closed. So most important thing is consumers. Thank you.
Best question award goes to him. Yeah, I think so. On defense, on the critical needs of India, absolutely. Tata Electronics always has supported, nation building. We have written a paper on made in India chips, meaning which are the sectors that should only procure from India because of the security reasons. We have shared that with the Ministry of IT and Electronics Technology. So we are definitely going to support that, like a secured fab within the fab, like you stated. So that's on the number one. We also think that just the critical needs of India can fill up almost 3/4 of a fab. We have done the bottoms-up assessment, and there are things like smart card chips used that are, chips that are used in smart cards like Aadhaar card, navigation chips for space and satellites, smart meters, base stations for 5G, 6G. These infrastructure items we would consider critical for the nation. And so if we roll up the demand for these chips, it actually turns out to be quite substantial. So we would be, as purely looking at it from a business standpoint, we would be very excited to support that as well. On your second question of where the demand is, so I think, like I mentioned, this, critical infrastructure need is quite significant. We have customers from within the Tata Group companies that have substantial demand. So that one significant advantage that we have. We have another set of customers that are suppliers to the Tata Group, that we want to make them our customers of Tata Electronics. So there is some advantage we have there. And then purely, I think there is a huge tailwind in terms of customers wanting to diversify their supply chain, and they're looking at India as a very attractive option from the geography, from the geopolitical neutrality standpoint, from the standpoint of the fact that he mentioned that India already has a very significant design ecosystem. So co-locating design and packaging and fab in the same location is advantageous for the customers. They're also looking at the Indian government and the decisiveness and the stability and the predictable nature of the government to consider India as a very favorable region. And they look at India as a very huge domestic market for their products. So all of these combined, I think, like they say, all stars are aligned for the demand.
So great. I think, we have to close the panel in the interest of time. So we will end with this, optimistic and positive note. All stars are aligned and also planets are aligned. Indeed, the planets are aligned. You don't miss that. You should see the night sky. And thank you again. Hope to connect with you very soon. Thank you.
Thank you.
Photo. Okay, I'm really sorry for that. We have come to the end, and I really thank Professor Navakanta Bhat for chairing this session and also moderating this fireside chat. And semiconductor certainly is one of the themes that we really wanted to cover extensively, but within 1.5 days, this is how much we could pack without actually digressing from the theme of the conference. So we are really thankful to all the speakers, the patron of the conference, the summit, the director IISc, Professor Rangarajan, the advisor, we had Dean Professor Anand Suresh. We had support from almost all government agencies that are in this ecosystem of technology diplomacy, starting from MEA as a host partner as well as various divisions of MEA. We also had support from National Security Advisor's Office. We had a huge support from IISc's administration. I would really like to place the gratitude and thanks on record to the administration, finance, and the entire organizing team that is put together IISc policy unit, Office of PSA policy team, as well as the administrative unit within the policy center of IISc. I think Dr. Rosa, Sambhavi, Shailaja, I think this is the only time I can actually acknowledge them in front of all of you so that they all get due recognition for the hard work they are putting in. And you might have seen the gang of people that are standing there and running around. This is the actual bunch who did all work. So I would like to actually call their names and request for a round of applause, because it's not an easy feat to like pull this conference together with just handful of people. I'll go by names. Animesh, policy fellow with us. Subarna, Dakshata, Nidhi, Arnav, Animesh, Abhinav. There are so many names I may even forget because sleep deprived, but we do have a few more research trainees consultant who joined us. And we also would like to place on record that the event is organized as a track 1.5 event, right? Which means the Ministry of External Affairs, Office of PSA and IISc jointly hosted this event. However, we did have substantial partnership from our partner countries. So all the diplomatic missions who extended their support, especially to begin with France and Australia, because France and Australia actually acted like a key partner countries to the summit with multiple high-level speakers and also curating some of the sessions. We have Professor Andrew White, we had Kathleen engaging with us on day-to-day basis, we had Consul General of Bangalore, Embassy of France, all of them working very closely with us, and we also had multiple closed-door sessions which are leading up to some of the high-impact engagement internationally in multilateral forums. So in that account put together, I feel this entire summit is resulted in something more impactful. We will be happy to share what those impacts are and insights are with all of you as delegates. And last but not the least, the delegates. So this is not those conferences where participants are passive participants, right? We curated the delegation in such a way that we had 1/3 of Government of India, senior level representation, joint secretaries, director, additional secretaries, secretaries to Government of India, and state government officials, 1/3 of industry representation internationally, nationally, and 1/3 of academic, scholarly, and public policy representation. I think that actually worked out very well in terms of having a proper mix of delegation, not just in engaging in conversation, but also in taking this forward beyond this summit. So finally, a big thanks to all of you who could make it to be part of this technology dialogue, which is exploring new ways and frontiers for tech diplomacy in India. And we look forward to continuing this of this event, but also as a continuous recurring event. Finally, thank you again. And high tea is arranged just outside this room. Please join us there. And some of the keynote speakers and others are still available for you to engage with, and please make use of this time. Bye-bye. And I request the organizing team and yellows to just stay in this room for 5 more minutes. Oh yeah, the organizing team, along with them, we also had summit ambassador coming from various public policy institutions, and I really thank Manipal. I also thank Kautilya Public Policy School, Ramaya Management School, and their faculty and public policy and management students who really helped in managing this conference through their student as summit ambassadors. And we would like them to remain in this room because we will be felicitating them. Professor Abhinandanan also to remain in this room. Oh yeah, I'm going to forget so many people from acknowledging, but before the last person leaves, our EMC team, thank you so much for supporting us with all these conditional support that we only received from this particular special room.